Hello, everyone, and welcome to another episode of Generative Geek. Today, we are going to talk about the latest OpenAI Agents SDK, and we are going to do a thorough deep dive by building a nutrition and fitness agent. We'll basically build two multiple agents, not just one agent, and I'm going to walk you through step by step of what are the various great features that this OpenAI Agents SDK offers, right? So to give you in a summary what OpenAI Agents SDK, and it's available on, if you just do a Google search saying OpenAI Agents SDK, the first link is their link, in the sense it's on platform.openai, and it talks about how you can build agents using OpenAI API and what are the various capabilities they have, including function calling, web search, and all of that. And there is a GitHub page which has a lot more documentation on how to use the SDK, what are the various things this SDK has, what are the various features, and we will talk about all of that as well. So the Agent SDK, if you look at it, gives you a very powerful framework for creating AI agents that can use specialized tools. If you remember my last lecture, we talked about what an agent is. And I said, you know what, an agent is basically a unit which has a brain. That brain comes from LLM, which gives it the reasoning power, right? So, and then you have memory just to recall what has already been discussed. And then there are various tools, and tools think of tools more like skills. As a human being, we have various skills, and those skills are used whenever we are in a certain situation to solve those problems. Tools is what an agent has access to, and tools is what it uses, using its brain to figure out which tool to call and in which sequence, so that it can then solve the problem, right? So it makes a plan, executes actions, reflects and iterates, all of that using tools, right? So if you come back to the OpenAI Agents SDK, you will see that it has various things. It has agents, some small set of primitives that it has. It has agents, it has handoffs. Handoffs is if there are two agents, how do they basically talk to each other, right? When does one agent call the other? Because the agents are not like a workflow. They are autonomous in the sense that they decide what action plan to take, right? So the handoffs are meant for that. And then there are guardrails, things like maybe the user. Now, you know what, one thing that has happened in the world of LLMs now is that anything you ask has an answer, right? So there is always an answer for any question that you ask. But that might not be very true in the world of in the real world, right? So let's just say, hey, I want to lose 30 pounds in a week. Is that something that is realistic, that is healthy? So the guardrails basically can be done for validating such requests, from both the inputs as well as the output that the agent is giving, right? So maybe the agent's output also needs to be validated. So guardrails is what OpenAI Agents SDK has brought out for that. So without any further ado, what we are going to do is we are going to build a fitness coach step by step, starting simple and then adding more advanced features as we go. And by the end of this, you will have a very clear understanding of how to build your own agent systems for any domain, right? By using OpenAI Agents SDK, right? So I'm going to start. This is going to be a maximum of 1 hour lecture. So I'll cover enough to get you started, right? And then my suggestion is take these basics, take the code that I'm going to provide, and build upon it and see where you go with it, right? These are all new things. I am also trying out and learning and then coming out on YouTube and sharing it with you. And I don't see a reason why you can't do it as well, right? So let's get started. I'm in a blank folder now. And what I'm going to do is, this is Visual Studio Code. I'm going to press Command Shift P. If you're on Windows, maybe it's Control Shift P, and bring in the palette. And I'm going to create a new environment, right? So I'm creating a new environment because I want to use that environment for all of the code that I want to write here, right? So I'm going to also create a new requirements.txt, and we'll have, if I go back, we should be able to figure out. It's called OpenAI Agents. So I'm going to have OpenAI Agents, and I need python.env because I'm going to have a .env file where I want to save my OpenAI underscore API underscore key, right? So this is the key that I'm going to use. So I'll come back. I'm going to use my OpenAI agents, OpenAI key, and I'm just going to copy this key and come back and paste. And don't worry, I'm going to change the key before uploading the video so that I don't expose the key. OpenAI agents and python.env. And now I'll go to the terminal and I'll install these dependencies, right? So let me come to the terminal and I'll install these dependencies. So I'm going to say let me just expand this. Pip install -r requirements.txt, right? So I'm installing these requirement files. As part of the Agents SDK, we are going to use specialized tools. We are going to generate structured outputs. We are going to hand off tasks to specialized sub-agents, implement safety guardrails, and maintain context through conversations, right? So it'll be an interesting one, and I'll do it as several files so that the first step, which is about structured outputs, let's get started with that. And structured outputs, in my experience, is like a very powerful thing. It's something without which basically when you bring in the structured outputs, you dramatically reduce hallucinations, which as compared to free form text, right? So what I'll do is I'll create a new file and we'll call it step 1 or agent structured output, or let's just say agent step 1.py, right? And I'm just going to say, and now let's go to the part where we'll start writing this code. So first, let's get started with importing all the necessary libraries. And what I'm doing is I'm importing async.io. Then I have Pydantic agents. Agents is coming from Pydantic. I'm using for structured output that I'm going to talk about. .env is for reading environment variables. And what we'll also do is we'll come back to our .env file and I'm going to say LLM model name. This is basically the model that we want to use. And I'm saying default is GPT-4o mini. And I'm going to come back to my agent step 1. So now that I have defined my import, I have defined all the imports, I'm now setting the model of choice. Next, what we'll do is, in order for the structured outputs to work, I'm going to set the structured output model. And this structured output model, let me just close the terminal. This structured output model basically is what we are going to ask the agent or the LLM to respond back with. So whatever is the query, the agent has to respond back. Let's say, because this is workout plan, this is a workout recommendation with exercise and detail. So we are saying what is the focus area, and we have a Pydantic field and where the description is primary focus of the workout. Is it an upper body workout? Is it a cardio workout? How is the difficulty like? Is it like, a beginner level, intermediate, advanced? What are the various exercises? And we are asking it to reply back with a list of recommended exercises and then any notes that it has. This, when you bring a structured output into play, what happens is now you are limiting the hallucination of the model. You are constraining the model. You're saying, hey, this is the kind of output I want. I don't want you to just go around and, give me any output. I want your output to be something like this, like, should have these attributes, right? Next, what I'm going to do is I'm going to bring in the agent definition itself, including the prompt. So we are saying we are building a fitness agent, and it's an agent where we are giving it a name. We are saying the name is basic fitness coach. Then we are giving it some instructions, and basis the instructions, we then will want the output to come back to us, right? So I'm saying, let me just format this. Yep. I hope this should be okay. Why is it closing this here? Okay. Your responses should be practical. Yep. So, and I'm going to share the code, right? So you can look at the code whenever you want. So you are a fitness coach who creates workout plans for users based on their goals. When a user asks for workout recommendations, determine their fitness goal, whether the goal is weight loss, muscle gain, endurance. Consider any information they provide about their fitness level. Create an appropriate work plan with exercises that match their goal. Include form tips and safety notes. Your responses should be practical, safe, and tailored to the user's needs. And then we are specifying what model we want to use, and the model is basically the model we have from the .env file. If nothing is found, then we are saying default to GPT-4o mini, right? And then we're saying output type is workout plan. Now this is which is enforcing the structured output. If I comment this line, and I can probably show you that, if I comment this line, the output is going to be whatever the agent wants to send back, right? So the agent is not going to follow this structured output. It's going to read this. It's going to read this instructions and say, hey, you know what? I know the answer for that, and just vomit the answer in a way, right? So what we are doing is we don't want that, and therefore we are asking it to present the output in a very structured way. And let me just show you what happens when we run it that way, right? You will get a sense. So what I'm doing is I have a async def main. This is our main method, and I'm saying my user query is now coming in. So these are the instructions for the agent, and says I want to build some muscle in my upper body. I'm a beginner and don't have much equipment, right? Next we are saying print /n, and these are all basically query is this query. It is going to print that. Then what it is going to do is in OpenAI Agents SDK, you have a runner, and you provide the agent and you provide the query, and this is how you call the agent, right? So and you print out the structured response, right? So whatever is the final output, you print that, and whatever are the notes, we are printing out the notes specially. Let me just remove this for now, and let's just print this for now, right? So I'm going to go to my terminal. The reason I'm going to terminal is so that we can have this open. So I'm going to go to the terminal, expand the size, and go to, let's just start it here, because the terminal, I'm in OneDrive, the code is in OneDrive, and so pwd clear, and I'm going to say Python agent step 1. Let's run this. And it's printing out the query. It's saying, hey, I want to build some muscle in my upper body. I'm a beginner and don't have much equipment. And now if you look at this, the structured response, it has a focus area. It says upper body. There's a difficulty, which is beginner. There are exercises which have come in as a list. And then there are some notes like, for push-ups, you should do this. For, and now let's just say if from this structured output, you had to just print out the exercises or the notes. This is how you print out the notes, right? So you will say whatever is the result.final output and the name of the node, right? Name of the attribute. In our case, the structured output had a thing called a notes, and so we are printing out the notes. Let's just run this once again. Now if you see, I'm running this once again. I want to build some muscle. Now if you see, it first gave me the structured response, and now it's giving me all the notes, right? So the notes that came it's printing all those nodes. And this is how you basically take a structured output and start using it for downstream processes, right? Next up, I'm going to build. So now what I'm going to do is I'm going to build tools, right? So our agent is able to do some things, but now what I want to do is I want to give it tools, right? So we have a brain that is coded. The brain is also given a prompt, a query, and some way by which the brain knows how the output needs to be processed, right? So it's all part of the prompt right now. What I now want to do is make the agent more intelligent by giving it the tools, right? So, and how do you give tools when you're using OpenAI SDK is, I'm going to close this and I'll come back here, is if you open the OpenAI Agents SDK page and you come down, you see tools, right? So I'm going to now, so we have done structured outputs. If I see results, does it have structured outputs? Okay, I'll probably show you another time what the, in a few minutes, where the structured output piece is. But this is how you give tools, right? So tools let agents take actions, things like fetching data, running code, calling any external APIs, right? So if you have an agent that probably has to take some action basis the weather, you will need a weather data, right? You will need live weather data. So tool is, or if you have an agent that has to search the internet, then you need a web search tool. You need to give that capability to the agent. So OpenAI offers a few built-in tools when using OpenAI responses model, like the web search tool, the file search tool, the computer tool, and all of that. We are going to use function tools here, right? So you can use any Python function as a tool. Think of it, you want to write any Python function. There's a function that maybe reads your database. There's a function that makes a call to your internal system, fetches all the sales records. That can be a tool. Right, so the Agents SDK will set up the tool automatically. The name of the tool will be the name of the Python function. Tool description will be taken from the doc string. Schema for the function inputs is automatically created from the function's arguments. Descriptions for each input are taken from the doc string of the function unless disabled, right? So these are like what important instructions that they give. And then the way you do it is you first import function tool from agents, and then you use this decorator called function tool, right? So this is the method. If you look at it, fetch weather is a method, and we have function tool that we have described, that we are using this decorator called @function_tool, and that decorator makes this entire function a tool, right? So we are going to use the same thing. We'll come back here now, and I'm going to start using our step 2. I'm going to start using the step 2 SDK, right? So similarly, what we are going to do is bring in all the code that we need to import. We'll also have, what was it called? LLM model name. So I'm going to have the LLM model name. Next, what we are going to do is we are going to bring in a workout plan, which is our structured output. So we have the structured output called workout plan, which you already saw. And now what we are doing is we are bringing in the tools, right? So first tool I'm bringing in is called the get exercise info. Think of it like, all the exercises that are available. We want to bring those into this agent, that capability into the agent. So this is my exercise info, get exercise info, where we pass in the muscle group as a string and we get back a string. This is the doc string, which says the function basically gets a list of exercises for a specific muscle group. Now, this could have been your database call here, right? Because in absence of a database call, what I've done is I've created some mock data and I've kept it ready. So we have an exercise data, which has various, it's a dictionary with key value pairs, where the key is the name, the muscle group, and the list has all the exercises. If you are doing chest, then this is the list. If back, then these are the list. Like that, we have that, and then we have muscle group. Whatever is the muscle group that is getting passed here, we are processing that. And if muscle group is in exercise data, if that key exists, then we just pick out all those that list. We return a JSON dump with the muscle group and all the exercises, and then we say this is the recommendation for muscle group training, complete all exercises with 62. This is hard coded, but think of it, if it was a more specialized API call, you could have had a more specialized recommendation, right? else return exercise information is not available, right? Next, I have another tool which is called the calculate calories tool. The goal is a string, whatever is your goal. Then it takes whatever is your weight in kgs, your height, your age, your gender, and the doc string is the more important part, right? So it calculates daily calorie needs and macronutrient breakdown based on user stats and goals, right? So this is another tool that our fitness and nutrition agents are going to use. Then it calculates the BMR, the basal metabolic rate, using Mifflin-St. Jeor ratio, Jeor equation. If gender dot lower in male, then this is how you find BMR. If it's female, then this is how you find BMR. Then we use a moderate activity level. We say BMR into 1.55. Then we adjust the goal. And this is how we basically keep going. And then if your goal is weight loss, then the calorie target is going to be whatever was calculated based as the moderate activity level minus 500, right? So we want to be like, because your goal is weight loss, we are going to be 500 calories deficit. Then if your goal is muscle gain, you want maybe more calories, right? So whatever is your moderate activity level BMR into 1.55, we are going to add 300 to it. And if it's just maintenance, hey, I'm all right, I just want to maintain where I am, then do take whatever is the BMR into 1.55, whatever is the TDE, right? So next, what we do is we calculate the macros. This is a tool. It could have done nothing and just returned back some random values, and probably that is what it is doing right now. So more important here is not to understand what this function is doing as such, but rather to understand that this is a function which has a decorator called function underscore tool, which makes it a tool, right? So, and the agent will know that it has access to this tool, and this docstring will tell the agent that, hey, this docstring and what it takes, right, will tell the agent how to call it and when to call it. Like, when the agent wants to make a plan and say, hey, when the agent wants to make a plan, it will be able to make a plan basis this docstring, right? So, and then we keep doing few other things, like, we say if the goal is weight loss, then you need 40% protein, 30% fat, and 30% carbs. If it is muscle gain, then 30% protein, 25% fat, and 45% carb. Again, some random values, don't worry about it. Finally, what we are doing is, after doing all of this math, we want to return back this JSON, right? So this JSON has goal, it has daily calories, it has the macros, protein, fat, and carbs, and we are returning this back, right? So this is the tool that the agent will call when it has to calculate the daily calorie needs, and it will get back a response, right? If this was a real thing, this implementation will have probably you will need a more sophisticated implementation here. This is a very, very rudimentary implementation. Again, now what we are going to do is we are going to create a fitness agent, right? So the same way we created a fitness agent in step 1, where if you remember, our agent had a name, it had instructions, it had what model it wants to use, and what is the structured output that it has to give. In step 2, again, the name is fitness coach with tools, right? That's the name we have given it. Instructions are, you are a fitness coach who creates workout plans and provides nutrition advice. Use the get exercise info tool to find exercises for specific muscle groups. So this is how we are telling the agent that this tool should be used to do this. Use the calculate calories tool to provide nutrition guidance. When a user asks for workout recommendation, determine their fitness goal, use the get exercise info tool to find appropriate exercises, create a workout plan that matches their goals. When a user asks for nutrition advice, ask for their stats if not provided. Use the calculate calories tool to determine their needs. Provide practical nutrition guidance based on the calculation. Your response should be practical, safe, tailored, and all of that, right? And then we say, this is how you tell the agent what tools it has access to, right? So in the prompt, we told the agent when should it use the tool. Here you are basically, this list called tools is actually tells the agent what functions it has access to. So if I delete calculate calories from here, even though in your prompt you say use calculate calories for making whatever, right? To determine their needs and all of that. When the agent really wants to do it, it'll say, hey, you know what? That tool was not found. I don't know where that tool is because I don't have access to that tool, right? So an output type is workout plan. Next, here what I have is some example queries. It's a list. So the first is, what are some good chest exercises I can do at home? Second is, I'm a 30-year-old male, 175 centimeter tall, and I weigh 80 kgs. How many calories should I eat to lose weight? Okay. Then we are looping through each query and we are passing it to the fitness agent. And we hope that the agent will make use of the tools and give us the answer, right? So let's go to the terminal. And I'll say Python Python agent step 2. Okay, what happened? Okay, the file is not saved, sorry. Yep. So let's try again. Python agent step 2, right? So what are some good chest exercises I can do at home? Okay, the response came. It says focus area is chest, difficulty is beginner to intermediate. If you have weights 8 to 12, and it gave all of that, right? So it is giving us, if you look at it now, if the focus area is chest, what are some good chest exercises? It automatically figured out that, we are talking about chest. Now let's just go back to the code once and see what was it that we had in our exercise thing, right? So for chest, we had, and see, the tool was called automatically by the brain. The brain calls the tool automatically. We don't have to specify, hey, this is how you need to call it, right? It called it. It figured out what muscle group were we talking about. It said chest, and then it called with that muscle group saying, hey, chest, right? And then for chest, if you look at it, these are the exercises that we have in our database. So push-ups, 3 sets of 10 to 15, bench press, 3 sets of 8 to 12, chest flies, incline push-ups. And if you look at our response that came back, it says the same thing, right? So push-ups, bench press, chest flies, incline push-ups. So the agent was able to use the tool. This is if I change the database here and I say, hey, don't do 3, do 4, right? And we rerun this, we should see, instead of this 3, we should see 4, right? So I changed chest flies. I hope I changed chest flies. So yeah, I changed chest flies, and I'm going to clear this and run this again. And if you look at it, it says now 4 sets of 12 to 15, right? So it's like it's like a database call. I changed the database entry. Agent made use of that tool, went to the database and said, hey, this is the new entry I'm getting from the database, and it's giving us that response back. And if you look at it, the response is in the structured output that we gave it. We said, hey, this is how the structured output has to be, and it's giving us back in that structured output. Now let's look at the other query. I'm a 30-year-old male, 175 centimeter tall, and I weigh 80 kgs. How many calories should I eat to lose weight? Again, look at it. Focus area is nutrition. Difficulty, there is no difficulty. Probably it's beginner, right? There are no exercises. Notes: to lose weight, aim for approximately 2711 calories per day. A suggested macronutrient breakdown is protein to 203 grams, fat so much. Consider creating a calorie deficit intake below this amount and incorporate exercises, right? So if you look at it, now it called the nutrition tool, and what it would have done is it would have called the nutrition tool. It would have calculated all of this basis whatever we gave it, and then this is the response that came back, right? So this is from where these notes are coming in. Like, it came back and it saw that this is part of the result. It added all of those things to the notes, right? Because in the structured output, there is no place to put calories and all of that. If you look at our structured output class that we are using, workout plan, it only has notes. There is nothing else. The exercises, there was no exercise prescribed. Difficulty was easy or something. So difficulty was beginner, exercises no, and notes, this is what it has added. All of the thing that it found from the nutrition calorie tool, it has added it here. So this is how you make use, this is how you give tools to an agent, and I hope you learned this part. Next up, what we are going to do is create two agents, a fitness agent and a nutrition agent, and do handoffs between the agents. So far we are seeing tools being used by one agent. Now it's like, hey, there are two agents and they are talking to each other, or they are doing handoffs between each other, right? So the handoff is nothing but an agent calling another agent, right? So let's get started. But before we go to the handoff section, let me quickly revise, or let's quickly recap what all we have talked about. So we talked about structured output as part of step 1, and the important part there is that we use Pydantic models to define exactly what our agent returns. That becomes our structured output. Each field has a description that guides the model's understanding, right? So model doesn't know what your field is about, right? The description that you write for that field helps the model understand what the context could be. Like, what is it that you probably want? Let's just say if the model had to derive the email address of the user from a text that you give it, unless you say, this email ID field that I'm talking about is the email address of the sender who sent the email or something like that, the model won't know which email ID you are talking about, right? So then you have the output type equal to workout plan that we are using ensures the responses follow this structure, right? So what are the insights here? First insight, which I talked about earlier as well, is that structured outputs dramatically reduce hallucinations, right? If it's a free-form text, you will see it hallucinating a lot, especially if the query is slightly broad. This is perfect for production applications. If you want, in production application, what you want is, prevention is better than cure. You want your downstream processes to get inputs, which are your outputs, in a way that they understand and they believe that you are going to do the right job and not send them anything which is not parsable, right? So it helps there. And think of these models as guardrails for creativity. They channel the AI's capability into a very useful format. Next, we talked about tools. And there I said, the function underscore tool decorator, it transforms regular functions into agent tools. Tools by themselves, in my previous video also I talked about, extend the agent's capability beyond what it is known from training. I'm reminded of this dialogue of Neo from Matrix, where it's like, hey, do you know how to ride the helicopter? And it says, hey, you know what, not yet, but now I do, right? So it's like someone feeding that training, that capability coming in, and it just goes on and shows what the agent is capable of. Tools always take typed parameters, so you have to always use typed parameters and return strings, often JSON. Agent decides when to use which tools. So you can have like several tools, and the agent will decide when to use what order to use. That is agent's calling. You have to define the functions in a way. But what I've also seen from experience is, the more the number of tools, the higher the chances of the agent feeling confused. So it's always better to make an agent for a very specific goal that you have, right? Not like, if you think there are two goals, like, a fitness plan and a nutrition plan, these are two separate goals, then divide them into two agents, give them their respective tools, and let the agent figure it out then. Instead of making one agent and giving it 5 or 10 tools, some fitness tools and some nutrition tools, the agent might actually start to hallucinate. You can try it on your own. I have done these things a few times, and it is from my experience that I feel you need a narrower boundary for the agents. Insight, what are the insights, right? This is how you connect your agents to databases. This is something I talked about in my previous video as well, where I showed you how to do that, the Telegram and the weather and all of that. Tools makes your agent truly useful, and always include descriptive doc strings for your tools. The agent reads those doc strings, right? So now let's get back to the coding part, where we'll do the handoff. So let's quickly go through the documentation on GitHub for handoffs. And I'll click on handoffs. And it says handoffs allow an agent to delegate tasks to another agent. This is particularly useful in scenarios where different agents specialize in distinct areas. For example, a customer support app might have agents that each specifically handle tasks like order status, refunds, FAQ, etc. And handoffs are represented as tools to the LLM. So if there's a handoff to an agent named refund agent, the tool would be called transfer to refund agent. Like, it's like internally, it's another function that basically is calling that agent, right? So that's how it all works, right? All agents have a handoff param. And look at this example, right? So it says from agents import handoff. Then there are two agents. One is called the billing agent and the other is called the refund agent. And then there's something called as a triage agent. And triage agent has handoffs, and it says it's a list, billing agent and refund agent, and you can define handoff function as well. Otherwise, each agent has a handoff available, right? So this is how you have the triage agent, and then there are various other things like how do you customize with the handoff function. You also have a method called on handoff, which you can have, which can call. Which can print saying, hey, you might have things like, hey, whenever a handoff is invoked, you might want to do a DB lookup or you might want to read some file, right? So all of that, it's like a constructor. Think of it like a constructor. You can, it's not really a constructor, but think of it like, if whenever that happens, I want to trigger this thing, right? So pub sub or whatever analogy you want to use, this function can be used to do those kind of things here, right? So this is the handoff object. You can do a lot of stuff like, my suggestion will be to go through this. This will really help you understand how to build effective handoffs. And I'm going to show you how to build a handoff myself as well, right? So I've created a file called agent step 3. And what we have here is again the same imports. We are loading the environment variables. Then we are picking the model from our env file. Then we have the structured output models. This time we don't have one, we have two. As you saw in my previous lecture, when we were talking about tools, even the nutrition was coming in this structured output. This time for meal plan, we have like a different structured output class. So we have daily calories, protein grams, carbs, fat, meal suggestions, and notes. Again, we have made use of Pydantic's base model and field. And we have very descriptive descriptions for each field, right? So that the model knows what goes where, right? And it's very important, therefore, to also keep right variable names, right? The thing is, the model is making sense of your problem. It doesn't know your problem fully. And these are small aids by which you keep the model guided, right? These are very large models. If you look at them, like 600 billion parameters, 200 billion parameters, you want to ground them somewhere, right? So these things basically help with that. Next, we have our tools. So the first one is the get exercise info, the same tool that we built last time. Next, we have the calculate calories, which is also the same tool. And then we have a specialized agent called the workout agent. So earlier we had just one agent called the fitness agent. This time we have a workout agent and his name is workout specialist. Handoff description is the specialist agent for creating workout plans. This is the handoff description. And these are now the system instructions saying, hey, you are a workout specialist who creates effective exercise routines. Use the get exercise info tool to find exercises for specific muscle groups. Now, this is how we are telling it that, hey, this is the tool, right? And in the prompt itself, create workouts that are appropriate for users level, always include form tips to prevent injury and all of that, right? Then we specify what is the model, which are the tools. It has only one tool that it has access to, and the output type is workout plan. Next, we have a nutrition agent. And we are saying nutrition agent is a nutrition specialist. Handoff description is specialist agent for nutrition advice and meal planning. Right? So if you go to handoff underscore description and you come back here, do a quick control F. The handoff description is not mentioned here. But if you look at the class, it is mentioned there. So this is basically it allows the agent to know when will it be handed off, right? On what kind of queries will it be? What kind of queries will this agent be called for, right? Instructions, you are a nutrition specialist who helps users with meal planning, use calculate calories tool. Same thing, same instructions that we had last time, just that we are specifying the tools this time. Output type is meal plan. Next, we have the main fitness agent. So we have made two agents till now. The first one was called the workout agent, and then we have the nutrition agent. And this time now we are making another sort of a triage agent, which we are calling the fitness agent. And we're saying fitness coach with specialized agents, right? So it is a fitness coach with specialized agents. We're giving it an instruction saying, hey, you are a fitness coach who helps users achieve their health and fitness goals. You can use tools to get exercise information and calculate nutritional needs. You can also hand off to specialized agents for more detailed help. So when the user asks specifically about workouts or exercises, hand off to the workout specialist. When the user asks specifically about nutrition, diet, or meal plans, hand off to the nutrition specialist. So we are telling it, hey, when do you want, when it's like another tool call, but now this time this is not a tool, this is actually an agent with a brain, right? So you give this, you have a set of things to do. Whenever it is about workouts, you give it, you call your specialist saying, hey, you know what? Hey, trainer, this guy wants to figure out what workouts he should do. Though I'm sitting at the reception of the gym, I can also answer, but it's always better to hand it off to the trainer, right? So when the user asks specifically about nutrition, diet, or meal plans, hand off to the nutrition specialist. Only handle general fitness questions yourself. For specialized needs, use the appropriate handoff. So you say what is the tool, then you model when you give it the tools. So it also has access to these tools, though it need not. Like, if you ask me, it need not. And we can try without the tools as well. Handoffs, and this is where you are defining how the handoff should work, right? So you have two handoffs, workout agent and nutrition agent. So now it knows, hey, these are the agents I can call and these are the tools I can call. And this is the model, like this is my brain. Now let's come to the main function. Earlier we used to have 2 queries, now we have 3. So I'm saying I want to start working out. What exercises should I do? How should I eat to lose 10 pounds in next 2 months? Can you give me some general fitness tips? So general fitness tips clearly is a general fitness guy's job. How should I eat should go to nutrition. And I want to start working out to lose weight, right? So how should I eat to lose weight pounds in 2 months? For query in queries, then we are looping through the query and printing out the response. We are only printing the final output. We are not printing out any specific nodes. So let's go to terminal, kill all of these. Clear, come back, come up, Python agent step 3. Yeah, I want to start working out to lose weight. What exercises should I do? Let's wait for the response. It should go to the workout specialist unless it fails. No, it came back. So focus area is weight loss, which it could figure out from this thing. It says difficulty is beginner exercises. Then it gives the exercise. And all of these must be coming from our database, right? So the tool that we described above, if you go up and you say, what is the focus area, must be coming from there. Focus area, weight loss, and what exercises is it saying? And we got some error where it says it got there's an error. I'll have to fix the error. Okay, I'll fix the error. But first, let's just see. It's saying, hey, you need to do weight loss. Exercises are walking for 30 minutes, jumping jacks, body weight squats, plank, bicycle crunches. These are the exercises it has given us, right? So, and next, how should I eat to lose 10 pounds in next 2 months? This is where it has bombed. So let's fix that first. So I reran and this time it has worked. So it says, I want to start working out to lose weight. Gave me the responses. How should I eat to lose 10 pounds in next 2 months? And this is the response. It gives the daily calorie, the protein grams, the carb grams, the fat grams, and then the meal suggestions and the notes. This is probably coming from our nutrition base class which we made for the structured output. Daily calories, protein grams, carbs grams, meal suggestions, and notes. So it's coming from our nutrition tool, nutrition structured output. This is what we had coded. Next, can you give me some general fitness tips? This should be handled by the fitness agent itself, which is our triage agent of sorts. I'll probably try rerunning it. It happened last time. I don't know if sometimes what happens is there could be API issues, and because of that, it might give an error. Okay, it came. Hopefully, it comes this time as well. Or the tool just the agent tries to run the tools a few times and then gives up. But that's not what is happening. I have a feeling the API is timing out. Yeah, I think it's the API is timing out, because maybe it's that time when it's 9:02 p.m. in India right now, which means maybe it's morning in the US, and somehow the APIs are timing out. So, but you get the gist, right? So this is how you build it. It should run. It was running. It's just that sometimes maybe because the error handling is not very comprehensive. One can even try that, hey, if OpenAI fails, go to another model, those kind of things. But that's for another time. So what is it that we learned as part of handoffs? So we said that each specialist has a very clear focused role and its own instructions. The handoff description tells the main agent when to use this specialist. And specialists can have their own tools and output types, right? The main agent decides when to hand off based on the query type. Think of it, this is how human organizations work, right? Generalists route to specialists. Handoffs lead to higher quality responses for complex domains. And this pattern scales to very complex agent systems. So my suggestion is go through the documentation, go through this code that I have given you, and try building these agents, right? This way, this is the only true way to learn. Finally, what we are now going to do is add two critical components. One is context and the other is guardrails, right? So what I'll do is we'll first come to the OpenAI documentation, the Python agents documentation, and we are going to look at how the guardrails are implemented, right? So when you come to guardrails, they say guardrails run in parallel to your agents, enabling you to do checks and validations of user input. For example, imagine if you have an agent that uses a very smart model to help with customer requests. You would not want malicious users to ask the model to help them with their math homework, right? So you can run a guardrail with a fast/cheap model, right? So if the guardrail detects malicious usage, it can immediately raise an error. So it's like the guardrail, think of it more like a classification problem, right? So you are trying to classify, is this allowed or not allowed, right? If it is not allowed, you don't even want to send it to an expensive model to do that compute, right? So and saves you time and money, and it can be done both on the input as well as on the output. So let's see what happens, right? So I'll just quickly go to the example. Let's say if this is the example, and it is called you import base model, then you import all the guardrail function output, input guardrail, tripwire triggered, run context wrapper, input guardrail. You import all of these. Then you have a class called class math homework output, which is basically a structured output. That is this a math homework and what is the reasoning? Then you have a guardrail agent. The agent is called guardrail check. It checks if the user is asking you to do their math homework, and output type is math homework output. Now, this is where you can actually have, let's say, a cheaper model. You can have a 4.0 mini or something like that do this for you. Then you define a math guardrail function, and you have the decorator input underscore guardrail with it. You pass the context, you pass which agent, and what is the input string and the list, right? So which will be a guardrail function output. Then it returns the guardrail function output with the output info and whether the tripwire was triggered or not. Let's say if the guardrail is triggered, then the tripwire triggered will get called, will be set to true, right? So let's say if the agent is agent, name is customer support agent. Now this is another agent. You are a customer support agent, you help customers with their questions, right? So input guardrails is math guardrail. You are giving it that, hey, this math guardrail, This is the guardrail that you need to check against. And then when you call the main, you run await runner.run. Hello, can you help me solve x 2x plus 3 equal to 11? And if this print happens, this was unexpected because the guardrail should have detected that, hey, the user is trying to solve for a math query. So let's implement guardrails. I have imported all the necessary classes first. And here what we are now importing, other than the function tool, runner and agent that we were doing till now and the handoff, we now have the input guardrail function output, input guardrail tripwire triggered, right? So these are the other things that we have now. Then we have, for maintaining the context, I have data classes, and for loading environment variables, we have .env and all that. Then we are loading the model. Next, we have a workout plan. This time a very simple workout plan. We are saying what are the exercises and what are the notes. Then we have a meal plan, daily calories, meal suggestions, and notes. These are again the structured output classes that we have been discussing till now. So I'm not going into the details of it. Then we have a goal analysis. This is for our guardrail agent. We want to see if a user gives some goal, is the goal even realistic, right? So we have is realistic, whether the goal is realistic and healthy, an explanation of the analysis. Next, for user context, we have a data class. So user ID, fitness level, fitness goal, dietary preferences, available equipments. This is like, hey, for all the users that are interacting with our agent, we want to maintain this user context, right? And keep passing it around. So we have next the guardrail agent. Earlier we had the guardrail base class, like, not the base class, but the Pydantic class for validating the structured output. Next, we have now the goal analysis agent, right? So the goal analysis agent is our guardrail agent. So you analyze fitness goals and determine if they are realistic and healthy. Losing more than 2 pounds per week is generally considered unsafe. And then you have an output type, which is goal analysis, and model is model, right? So we can easily have another model here, which is the cheaper model like I discussed, but for keeping things simple, I'm using just same model right now. I'm anyways using GPT-4 Home Mini. I could have used here you can use even cheaper models like, Microsoft V4 or something like that. So here we have the goal analysis is our structured output that we are looking for. Next, we have a method called fitness goal guardrail. Which takes the input data and if checks if users input fitness goals are realistic and safe. This is the analysis prompt. The user said, analyze if their fitness goal is realistic and healthy. Then we call the goal analysis agent and the analysis prompt, and the final output is then taken. If the guardrail, we then return the guardrail function output, and if the tripwire is triggered, then we know that the tripwire got triggered and the guardrail has got hit. So we'll see all that. Next, if there is an exception, we return guardrail function output and we say whatever is the output info. So here is realistic. We say we are saying this is not triggered. Here we are saying this is got triggered, right? Tripwire triggered is false. Sorry. If it was not triggered, we are setting tripwire triggered to false. Otherwise, it gets set to true. So workout agent, we are passing the user context. We are saying this is a workout specialist agent for creating workout plans. Next, we have all the instructions saying, hey, you are a workout specialist. Consider the user's context, fitness level, all of that. Create a workout plan. I'm going to give the code. So anyways, you can look at the code later. Nutrition agent. It is a nutrition specialist, and you are a nutrition specialist who creates plans and fitness goal, dietary preference. Output type is meal plan. Then we have the main fitness agent. Again, we are passing it the user context, and then we are giving it all of the information saying you are a fitness coach. When user asks about workouts, hand off to the workout specialist. When users ask about diet or nutrition, hand off to the nutrition specialist. For general fitness questions, answer directly, and we are giving it the handoffs. We are giving it the guardrails. We are also, so this has access to guardrails. If you see the other two agents, they don't have the guardrails, right? Because this fitness agent is the main agent, right? This is the one that is going to get called. All the queries are going to come to him. This agent has access to the guardrails, right? And now we have the demo function. So we are saying first we define the user context. We're saying user ID is 123, beginner, weight loss, no restriction. I have dumbbells and resistance bands. And then these are the queries. I want to start working out to lose weight. What exercises should I do? Can you give me some general fitness tips? And I want to lose 20 pounds in 2 weeks. This should trigger the guardrail, right? So hard-coded meal plan to avoid complexity. Earlier we had a very complex function, so I've simplified that. We have a meal plan response, and we have hard-coded all of this, right? So whatever was the structured output, we have hard-coded that here. Then for query in queries, add a special case for nutrition query to avoid complexity. If how should I eat in query.lower, or meal plan in query.lower, or nutrition. So we are saying, hey, when should the nutrition specialist be called? And we'll print the meal plan response. We are not actually making that call. For other queries, use the regular agent. Basically, my idea here was to just show you how simple it is to create these handoffs and to create these guardrails and focus on the core rather than actually building a solution which you can deploy in production, right? So result is await runner.run. We are calling the fitness agent. Sorry, something happened. Yeah. Query, then I'm passing the context. And then like this, you can actually check which agent was called. If is instance result.final output was workout plan, then we are printing out this saying, hey, workout specialist got called. If it is meal plan, then we know nutrition specialist got called. If it is otherwise, we know the main fitness coach is answering. And then if the guardrail gets triggered, then we have an exception and we say, hey, the guardrail has got triggered. So let's run this demo now. I'm going to save this, come to the terminal and just take this up, clear Python agent step 4. I want to start working out to lose weight. What workout should I do? I really hope it does not get stuck in the tool calls. So it's saying workout specialist was called and the response is brisk walking or jogging, and it's giving me all these exercises, right? Next, can you give me some, I want to start working out. Okay. Can you give me some general fitness tips for a beginner? And says main fitness coach answered that. And there is some answer. And then I want to lose 20 pounds in 2 weeks. And you can see a guardrail got triggered, right? An unrealistic or unsafe fitness goal was detected. So anytime, so this is how basically you code these agents. I hope today's lesson was useful. We went from the start. And let's just quickly recap what all we have learned, right? So we first did structured output, then we did tools, then we did handoffs. So for guardrails and context, we learned that the context stores user information that persists across queries. Type annotation agents, user context, agent with the user context gives agent access to this context. Guardrails prevent harmful or unrealistic advice. And the input guardrail system intercepts queries before processing. I have not demonstrated the output guardrail system, but it's very similar. Like, this is how you actually do the input guardrail and the output guardrail. Output guardrail is like, several agents, and then you push it to the guardrail before you give it to the final agent, right? So just to see if everything is okay. Context is how you personalize responses. These are all the insights now. Guardrails are essential for responsible AI development, and you can create multiple guardrails for different safety concerns. It's not like, again, guardrail is basically a list. You can have several of them, right? So, this is what I wanted to demonstrate today. We covered structured outputs, we covered tools, we covered handoffs, and we covered guardrails. Play around with the OpenAI Agents SDK. It's a very powerful SDK. And I hope you will learn something new, something interesting when you do that. And I hope this lesson taught you something interesting, right? So if it did, please do like, subscribe, and comment. It gives a lot of motivation to small creators like me who want to share their knowledge, the knowledge that people like me are gaining while learning new things. So generative AI is a very, very is at a stage where new things are happening every few days, and it's always useful to stay in touch, keep updating your knowledge and keep learning. So if you learn something new, something interesting, do share, and that's all I ask for. Thank you so much.